Hi everyone, welcome to your first video lesson. The title of this lesson is Solving Multi-Step Equations, and this is going to be in the first subject of your 3-subject notebook, and this is covering lessons 1-1 and 1-2. We're going to start each of these lessons with a driving question. So this time our driving question is, how can I determine if an equation has a solution? So there's going to be some times where there's no solution or something called an identity. And if so, what that solution is. So remember that we are using the Cornell note format, so that means that questions should be going in the left margins, and then any notes and images, etc. Should be going underneath the driving question. Now remember, you're not actually writing what's in those blue parentheses. That's just to let you know that that's what should go there, but you don't actually have to write that down. Now we're going to start the actual lesson. This next piece is directly from the textbook, so it's called The Essential Understanding, really the meat of this lesson. So to solve multi-step equations, you form a series of simpler equations. So in other words, you're going to be performing a series of steps. So to do this, you use the properties of equality, inverse operations, and properties of real numbers. By the way, those 3 things mentioned you're going to be learning through, or maybe have learned through, in-class activities. You're going through some stations, so don't worry about that right now. And you're going to use these properties until you isolate the variable. So the big key word here is isolate. That's our main goal. So we're always going to be isolating the variable, doing several steps. I know this might look intimidating, all the words at once, but don't worry, it's not too bad. So we're just going to dive right in. I feel like students normally best learn through examples. So we're starting off easy when there's a variable or a letter, like in this case m. There's going to be a lot of different letters on only one side of the equal sign. So in this case, our task is to solve 5 equals 5m minus 23 plus 2m. So the first thing that we're going to do, since we have 2 m's there and I only want 1, we need to combine them together since they're on the same side of the equal sign. That's going to give me 7m. And that minus 23 is still there, as well as that equals 5. Now remember that the goal is to isolate that variable. So I want to get that m by itself. I do this slowly by first moving that negative 23 away. So I have to move it to the other side of the equal sign. And I do that using an inverse operation. So since it was minus 23, I have to do plus 23 in order to move it over. So that gives me 28 equals 7m. To finish the problem, I do have to get that m completely alone and get rid of that 7. Since that 7 and that m are being multiplied together, the inverse operation of multiplication is division. So I divide by 7 on both sides, and 28 divided by 7 is 4. And I do want to box in my final answer. So I typically get the question, how come in the beginning you added the 5 and 2 together, but then later on you do different things, like you do the opposite or inverse sign? Well, just to let you know, that's because if 2 things are on the same side of the equal sign, it's like they're allies. They're going to combine together. But if 2 things are on opposite sides of that equal sign, or I need to move something over, then you're going to do the inverse. So again, if they're on the same side, like that 5m and 2m, you combine them. If you're trying to move it to the opposite side of the equal sign, like moving the 23 over or getting rid of the 7, you do the opposite operation. Here's our next example. This one has variables on both sides of the equal sign. So we have to solve 3n plus 2 equals negative 2n minus 8. We're going to solve this very similarly to the first example. The only difference is that there's one more step. First, we take the time to move all the variables to one side, and then we can continue just the way we did before. So I added 2n to both sides, so that way it moves that negative 2n to the left, and I end up with 5n plus 2 equals negative 8. Now I can solve that just like before. So we subtract 2 from both sides to get that 2 away from that 5n, and then we divide by 5 to get the n completely alone, and n equals -2. By the way, I know that I'm going through this rather quickly. Feel free to pause, rewind, or re-watch as much as necessary. Just a little note while I'm here, make sure you try and keep your work organized. Math is a lot easier when you can see things done step by step. If you notice, I always keep that equal sign right in the middle and move it down. It should never just disappear. A lot of students tend to just make their equal sign disappear and I don't know where it goes. So make sure that you can follow along with each step in your work the way you can do in mine. The next problem is now shown. Notice that it involves some distribution because you see that set of parentheses there after the 5. You do have to distribute that 5 first in order to get rid of those parentheses, ungroup that whole section, and then you can continue to solve the problem. So once I distribute, that's what it looks like. Remember to multiply the 5 with everything that's in the parentheses. And then you continue to solve the problem as we had shown in the steps before. Notice that this problem does involve some decimals. Don't be scared. There will be some messy numbers in this course. There won't always be perfect integers. But either way, you can follow along. Notice that at the end, our final answer is also a decimal. A equals 1.03. As you are writing all of this in your notes, I want to make sure that you're not simply just writing what you see on the screen. Make sure that you understand each step of the problem. If you do not, make sure you write a question on that left margin of yours, so that way you can remember to ask in class, because eventually you will be quizzed and tested on this. Also, you will be eventually issued a calculator, but since I'm not there yet, I will allow you to use your own calculator or maybe even a phone calculator, assuming that it's used only for that purpose. If you do not have a calculator or for some reason your device privileges are taken away due to inappropriate use, then you do have to divide or multiply by hand. So maybe it was a long summer for you and you don't really remember much about distribution. Here are a few notes. You can distribute on both sides of the equal sign at once, so that's something we're going to have to do in the next problem. Notice that there's a 2 in front of parentheses as well as that 4 in front of parentheses. You have to multiply with everything that's in those parentheses. A lot of times we only multiply with the first thing and forget to multiply with the second or maybe even third or fourth things in those parentheses. And don't forget about signs. So here in the very beginning, it's actually a -2 as well as a -4. You have to remember about multiplying those signs in. If you end up with a negative times a negative, that is a positive. So let's continue to solve this one. Once you do that distribution, you end up with this equation. And then you continue to solve as with all the other examples. You want to get all your variables to one side and then all of your constants to the other to isolate that variable. And we end up with f equals 2. Now in every other problem I had moved the variable from the right to the left hand side of the equation. But notice this time I did not. I actually moved it from the left to the right side of the equation. Either way is okay and correct. Either way you will end up with the same answer. However, in case you're wondering why I did that, I just happen to like to keep things positive, especially those variables positive, if it's possible. So that's the reason that I moved it the other way. Oops, let me go back. Because I was able to add 4 to both sides to end up with a positive 8f. If I would have moved it from the right to the left, I would have ended up with a negative 8f. Again, either one is okay and correct. I just happen to have done it this way. The next example problem is shown in blue. This one has that negative sign right in front of the parentheses. Now, even though there is no number there, this is still a distribution problem because it's that invisible one, technically. So you have to incorporate that negative, or you can think about it as multiplying everything in the parentheses by -1. So we end up with negative 8x minus 3x minus 6. Don't forget that negative goes with both of the things in the parentheses. Equals 4 minus x. Next, we combine like terms so that negative 8x and negative 3x combine to make negative 11x. We move all of those variables to one side. In this case, I moved them from the left to the right just because I wanted to keep them positive. And we end up with a negative 6 equals 4 plus 10x. Since I want to isolate the variable, I do now have to move all the constants to the opposite side from the variable. So I had to subtract 4 from both sides. Negative 6 minus 4 does make negative 10. And to completely finish the problem, I did have to divide by 10 on both sides to get that x alone, and x equals negative 1. This was just sort of a recap of everything that we've done so far. So just remember all of the different things like distribution, combining like terms, moving the variable to one side, the constants to the other, and using inverse operations to completely isolate the variable. This next problem is a little bit different, so make sure that you write this one down. I see 3x plus 7 equals 14 plus 3x. And as I would normally start working out this problem, I want to get all my variables to one side. So I subtract 3x from both sides. But when I do that, all of the x's go away. And I'm left only with the 7 on the left and the 14 on the right. So what does this mean for us? This is impossible. We can't have 7 equal to 14. Those are obviously not equal. So this is a problem that actually has no solution. Remember, we talked about how there might be a time when the problem doesn't have a solution, and this is one of them. So you might wonder, how can I easily figure out if a problem doesn't have a solution? Well, if you notice, the 3x matched on both sides, the number in front of the variable, but the rest of the numbers, that 4, that 14 and that 7, don't match. So if you see, again, the variable and the number in front match, but the rest of the problem does not match, it's going to be no solution. And in case you're wondering, what does no solution really mean? That means that no possible value for x could make both sides equal. So no matter what number you put in there, you could try fractions, you can try decimals, none of those values would work. Now here's another problem. I see 4 times, in parentheses, 3m plus 4 equals 2, in parentheses, 6m plus 8. So as we would normally start working out this problem, we would distribute that 4 and that 2. And then we end up with 12m plus 16 equals 12m plus 16. Well, in this case, both sides of the equal sign are identical, exactly the same. So when we have both sides exactly identical, that means it's an identity, meaning that all values would work, or there's infinite solutions. So no matter what number you put in there, every single value would work. So here's a little demonstration. So let's say we plug in the number 1 for m. On one side for times 7 would be 28. And then on the other side, 2 times 14 would be 28, and that matches. Let's say now we tried m equals 2. Well, on one side we'd have 4 times 10, which is 40. And on the other side, 2 times 20, which is also equal to 40. So that matched. So that completes the lesson. Now that the lesson is over, remember to write a lesson summary at the end of your Cornell notes and write any lingering questions in the left margin. I know this first video was a little bit rough with my editing. I'm a little rusty from over the summer, and this might be one of your longer videos, but we'll continue to have video lessons. Make sure to ask your peers if you have any help, or you can always send me an email. I'll see you guys soon. Bye.